Okay, let's look at the limits at infinity. Right? The difference between limits at infinity and the infinite limits is that in this case, x approaches either negative infinity or positive infinity instead of the function value going to positive infinity or negative infinity. Alright, so instead of looking at the definition, let's go dive right into the examples. Alright, so limit of x cubed plus 2x squared minus 5 as x approaches negative infinity. Right? So first thing we do is we're going to factor out the leading term. Right? So you're going to have a limit as x approaches negative infinity. Right? So leading term in this case is x cubed. Right? So this guy will be factored out. So I'm going to just factor out x cubed. Alright, then if you factor out x cubed from x cubed, you're going to get 1. Alright, if you factor out the x cubed from 2x squared, maybe we'll do it. It's factoring out is basically a division, so I'm going to just write it as 2x squared over x cubed. Right? And the negative 5 over x cubed, so it's going to be negative 5 over x cubed. Alright? Then clean up a little bit so you have an x squared on top, so you can cancel that. And you can cancel 2 of them, so you have another x. So if you clean it up, you're gonna get this. This is going to be a limit as x approaches negative infinity of x cubed. Right? It's probably better to have a bracket around here so that that goes on the limit. Right? So here's a bracket here. Right? One's nice. Right? This is already cleaned up, so you have 2 over x. Alright, the last term looks nice, so I'll keep that. 5 over x cubed. Alright, then think about where these guys go. Alright, so as x approaches negative infinity, 1's going to stay 1. Alright, but this guy right here, 2 over x, 2 divided by negative huge number. 2 divided by huge number is going to be very, very close to 0. So this approaches 0. Right? And also, 5 divided by negative infinity cubed. So it's going to be 5 divided by a very, very big number. So that's going to be approaching 0 as well. Right? Then here, so if you have negative infinity cubed, so negative infinity cubed would be, alright, sign wise, a negative number cubed is going to be still negative. Right? Infinity is you can think of a really, really big number, and to raise it to the third power is going to still be a big number. So it's going to be a negative infinity here, multiplied by basically 1. So it's going to be just, so maybe I'll just multiply by 1 plus 0 is going to be 1, which is going to be, of course, negative infinity. Alright, so that's that. Alright, then we can do the similar thing with the rational function. Alright, so we want to take the limit of 5x cubed minus 2x squared plus 1 all over 4x cubed plus 2x minus 7 as x approaches infinity. Alright, so for this one, what we do is we're going to divide top and bottom by the highest term on the denominator. In this case, x cubed right here, right? So divide numerator by x cubed, divide denominator by x cubed, right? So what you get is, okay, so you still have to take the limit as x approaches infinity, right? So 5x cubed divided by x cubed would be x cubed cancel out. So you're going to get just 5. So you have 5 here, right? Right, negative 2x squared over x cubed would be 2x's cancel out. So it's going to be x on the bottom. So it's going to be negative 2 over x, right? 1 divided by x cubed would be 1 over x cubed. 1 over x cubed, right? And on the bottom, 4x cubed divided by x cubed would be 4, right? So we have that. And negative 2x divided by x cubed would be positive 2 over, right? Only one of the x's cancel out, so you have x squared instead of cubed, right? Then negative 7 divided by x cubed is negative 7 over x cubed, right? Then you can see that this is much easier to evaluate. Think of x is getting larger and larger and larger. All right, so here, this term, all right, 2 divided by huge value is going to approach 0. 1 divided by big number cubed is going to approach 0 as well, right? And you have 2 divided by big number squared, so that's going to be very close to 0. Right, negative 7 over a very big number cubed is going to be approaching 0 as well. Right, so what's left is really only 5 on top and a 4 on the bottom. Right, and that's the limit. All right, so that's kind of how evaluate the limit. Right, but if you have a polynomial function like the first example, or a rational function like the second example, there's a trick to evaluate the limit in a very much shorter way. All right, so let's do that. All right, so this is the same example. All right, so what you can do is when you take the limit at infinity of a polynomial function, all you really have to do is look at the leading term, right? Then ignore the rest of the terms, right? Then think about, okay, plugging in a negative big number. So negative big number cubed is going to be, all right, negative number cubed is going to be still negative, right? Big number cubed is going to be still big, right? So that's why you get negative infinity, which is exactly the same answer as the first method here. All right, and the next one, if you have a rational function, and what you can do is pretty much the same thing. You only look at the leading term on top, then ignore the rest, and a leading term on the bottom, and ignore the rest. And then you can just take the limit of that. So it's going to be a limit as x approaches infinity. All right, so you have 5x cubed is the leading term on top, and a 4x cubed is the leading term on the bottom. All right, then x cubed on top and x cubed on the bottom cancel out. If you take the limit of constant 5/4, it's always the same constant. So you have 5/4 is the limit. All right, so basically, if you want to take the limit of a polynomial function or a rational function at infinity, you basically look at the leading terms. All right, that's that, and you can see that we get exactly the same answer here and there as well. All right, that's it. I hope that this was clear.